So are we good?
Yeah, welcome to the VPIM for State Project 96-209, bridge number 01214, carrying Schoolhouse Hill Road over I-84. We're just waiting a couple of minutes until some attendees trickle in here, so please be patient. We'll be starting shortly. We'll just wait another minute and we could begin Francisco.
Sounds good.
We're ready, Francisco. You could get started with the VPIM.
Okay. Good evening, everyone, and thank you for joining. Please feel free to take the time to visit our project webpage to learn more about this project. Our admin staff will be posting the webpage link in the chat box shortly. So this is, as Isa said, is the virtual public information meeting for project 96209. This is a superstructure replacement of Bridge 1214 carrying Schoolhouse Hill Road over I-84. Here's the overview of our meeting. First, I'll start with the housekeeping where we introduce our team. Moving on, we'll have a formal presentation of the design where we're gonna share the existing conditions, the project purpose and needs, the proposed improvements, the construction schedule, and last, we're gonna hold a live question and answer session. Before we start with the presentation, we want to notify you of the Title 6, which is your civil rights. No person shall, on the basis of race, color, and nation origin, be excluded for participation or subject to discrimination in the development of this project. There is a voluntary post-meeting survey with a QR code next to it. We have the civil rights information in the link below. Also, there is a recording of this presentation will be posted onto YouTube after the event. A closed caption including non-English translation options are available on Zoom and YouTube. Here is some information on the Title 6. You can access this information on the link provided previously for the civil rights information. This is here an instruction on how to view the captions and subtitles in Zoom. First, we'll click to show the captions button at the bottom of the webinar. Then we'll click on the speaking language button and select the language that we like from the list below. As a reminder, a closed caption including non-English translation options are available on YouTube after the event. You can reach us on you can reach us on the Q&A using the following channels. First, you can reach us by emailing us at dotproject00960209@ct.gov. Also, you can also reach us by phone. You can call 860-594-209 at 2020 to leave us a voicemail. You can also call us at 860-594-2078 to reach Francisco Fadul, who is a project manager. You can also reach us through the Q&A. There will be have more instructions for that on the next slide. And lastly, you can visit the project website at portal.ct.gov/dot Newtown 0096 CO209 for more information on this project. Please note that this Note that the comment period is open through September 3rd, and the sub Q&A is only available during the live Q&A session. Here is some information on how to use the Zoom Q&A. First, select the Q&A tool on the bottom of the Zoom webinar window. Second, the Q&A window will open as seen in the right. And third, please type your question in the text box and click enter. If you're an audio-only participant, please dial *9 to raise and lower your hand. Next, I'm going to pass it over to Daniel Claff from Matt McDonald. He will be here and introduce the project team along with the design we have developed for this project.
Great, thank you very much, Francisco. Again, my name is Daniel Claff, and I'm with the design team. And I'll start by introducing the rest of the design team. So first, from Connecticut DOT, we have Greg Funk, Francisco Fadul, and Isu Flashy. Next, please. And then for our consultant liaison engineer, we have Don Wurst and Francisco Garcia. And as I mentioned, I'm Daniel Claff. I'm with Mott McDonald and the project manager from the design team. And I'm joined by Sam Martha, who is a traffic engineer with V Engineers, and Frank Billetier, who's also a member of Mott McDonald, doing the highway work. Next, please. So the reason that we are here today is to talk about a bridge that crosses Interstate 84 in Newtown. And this current bridge was built in 1962, and over time it has developed some deterioration, and that deterioration is going to require us to do some rehabilitation to bring it back up to a full working level. So in this presentation, we'll talk about the existing bridge. We'll talk about where it's located and its current function, and we'll talk about the proposed replacement as well. Next, please. This satellite view shows the area around the bridge. The bridge is marked where the red callout is. It's on Schoolhouse Hill Road near Newtown. In this satellite view, Newtown is located towards the bottom of the image. And for reference, Sandy Hook Village is located in the top right. Our project site, again, over Interstate 84, is adjacent to an industrial park on the southeast, just below where Interstate 84 is shown. And it's also bordered by a residential area on the northeast side. Next, please. As I mentioned, the bridge was originally built in 1962, and it's only had one major rehab effort, and that was in 1994, and it primarily consisted of painting. So this is an old structure and will definitely need some work performed. As you can see from the top image, which shows Schoolhouse Hill Road, the existing bridge is 36 feet across in terms of the roadway width. And it consists also of concrete parapets along the edges of the road and a functionally obsolete steel railing on top of the parapet. The current road here is a 25-mile-an-hour road, and it services approximately 1,100 vehicles per day, of which 4% of those are truck traffic. On the bottom, you can see a view from Interstate 84 of the bridge itself. We'll talk a little bit more about the structure in the coming slides. Next, please. I want to talk a little bit about the existing roadway conditions first. The last inspection of this structure took place in 2025, so about a year and a half ago. During the inspection, various elements of the structure were given a rating, and this rating goes from 1 to 9, with 9 being the highest possible rating. So from a roadway perspective, first we have the north approach and south approach, which are the left and rightmost photos. As you can see, these areas that are adjacent to the bridge exhibit cracking in the asphalt. Likewise, the middle photo shows a deck joint, which essentially is a gap in the structure that allows the bridge to expand and contract. Here, this joint has deteriorated and has had a repair to it with tar filling the gap. The problem with the cracks in the deck and in the asphalt alongside the bridge is that water goes through the cracks, and then in the case of the roadway, it causes the roadway to heave during frost, or in the case of the bridge, water that goes down into the bridge will cause the bridge elements to corrode and rust over time. Next, please. The photos on this slide show the structure itself, and I'll start here with the middle photo. In this middle photo, we see that there are 5 steel girders. These run up and down the photo. The purpose of the girders is to provide the predominant strength to the structure and to support the roadway above. The girders are connected from left to right with what we call diaphragms, and the purpose of those is essentially to space the girders and prevent deflection. Also between the girders, you can see a concrete deck. The underside of this concrete deck is serving to support the asphalt that we drive on. So the concrete slab is a very important element of the structure. So altogether, these elements, that is the girders, the diaphragms, the concrete deck, and the asphalt, represent what we call the superstructure of the bridge. Also in this middle photograph, at the back of the photo, you can see what we call an abutment. So the purpose of the abutment is to convey the weight of the structure, that is the girders, the deck, the traffic that's on it, down into the soil. In addition, the abutment serves as the interface between the bridge and the roadway beyond. Now, if you look at the left photo, you'll see what we call the bearings. The bearings are assemblies that support the girders above them, and they rest on top of either the abutment or a pier. The purpose of the bearings is twofold. One, it's to convey the loads from the structure, as we just talked about, down into the concrete abutment. The second purpose is to allow for the bridge to expand and contract with thermal changes. Therefore, over time, if water comes down from the deck into the structure, the water will cause the bearings to rust, and this corrosion actually locks up the bearings, preventing them from expanding and contracting. In the rightmost photo, we see what we call a pier, and the pier is an intermediate support that, like the abutment, conveys loading from the deck down to the ground. So as you can see from the table, our substructure elements are overall okay, whereas the superstructure elements are in slightly worse condition with ratings of 5. Next, please. So as a result of what was observed in the inspection, it was determined that the best approach to follow would be to do what we call a superstructure replacement. Essentially, we'll give the structure a haircut, we'll take away the existing superstructure, and we'll put a new superstructure on top of it. So what will happen is we will take off the existing railings and parapets, the existing asphalt, the concrete deck, and the existing girders. When we've taken all those things off, then we will perform repairs to those piers that we saw in the previous photo. You can see those in this slide, which shows an elevation view of the structure, which is essentially as if we were driving along Interstate 84 and about to drive under the bridge. Those repairs are the areas hatched in red. Once the repairs are done, then we will install new bearings. And then on top of the bearings, we'll install new girders, a new deck, new parapets, and finally, we'll install a new chain link fence on the parapets. Next, please. This slide shows a cross-section of the new structure. Essentially, this is as if we took a cut through Schoolhouse Hill Road as if we were driving along that. So in this view, we don't see the piers or the bearings or the substructure, but we only see the superstructure. Again, here, the girders, the steel girders are in orange. They're the I shapes. And then those are supported by a concrete deck, which is purple and black. The parapets and chain link fence, which are pink, and the asphalt driving surface, which is in yellow. Now, one goal of ours is to do this project as quickly as possible for a number of reasons. And to achieve that, we're going to use a technique that's called accelerated bridge construction. With this technique, sections of the bridge are going to be built off-site, and then they'll be brought in on huge movers called SPMTs. So you can see those chunks in this cross-section. Each chunk consists of 2 girders and the purple area of concrete on top of it. So an SPMT crawler will bring in a unit. The unit will be hoisted into place. And then once all 3 of the units are brought in, we will perform a closure pour, connecting the units with an area of concrete, and that area is shown in black. Overall, this should make the construction of the bridge much faster than if we employed typical construction techniques. Next, please. This slide shows an aerial view of the structure, and we'll use it to demonstrate our roadway impacts. So the orange in this slide represents the steel and concrete superstructure that we have been looking at. And you can see from top to bottom in this picture, we have Interstate 84, which runs underneath the bridge. To the left of the bridge and the right of the bridge, we will be doing roadway maintenance. It'll be approximately 250 feet on either side, which is almost the length of a football field. The yellow areas represent full depth reconstruction, which means we'll pull up the entire roadway and put down a brand new roadway surface. The pink represents mill and pave, which means we're essentially just grinding off the surface of the roadway and we'll pave down a new asphalt layer. In addition, we'll add brand new guide rails, which are shown in blue. And finally, we'll perform some grading and earthwork to restore the embankments adjacent to the structure. Next, please. And with that, I'd like to pass the floor over to our colleague, Sam, who will talk about the traffic impacts on the project.
Thanks, Dan. Good evening. I'm Sam Martha with VN Engineers, and we are the maintenance and protection of traffic designers for the project. The goal of maintenance and protection of traffic is to design plans for the contractor that provide safety for the construction activities while limiting traffic congestion or delays for the traveling public as they navigate through the work area. This project impacts 2 roadways, Interstate 84 and Schoolhouse Hill Road. This slide shows the overview of the long-term temporary traffic pattern that the contractor will implement on 84, running underneath Schoolhouse Hill Road. This traffic pattern uses advanced warning signs, temporary pavement markings, and traffic drums to narrow the lanes from 12 feet to 11 feet and shift the traffic towards the median. This shift provides the contractor with the space required to install the temporary traffic barrier. This barrier provides positive protection for the construction workers, construction equipment, and I-84 traffic as construction progresses in both outside shoulders. On this slide, the lane shift is highlighted in yellow and the work area is highlighted there in orange. In addition to this long-term stage, the contractor will also be allowed to close 1 lane, leaving 1 lane open during allowable off-peak hours. These allowable hours are provided to the contractor and use recorded traffic volumes to determine the hours of the day where volumes are low enough so that the lane closure would not cause significant traffic delays or congestion. These are the extents of the traffic impacts on 84, and in the next slide, we're going to look at the impacts to Schoolhouse Hill Road. Thank you. So in order to facilitate and expedite the superstructure replacement of the bridge, as Daniel mentioned, the bridge in this portion of Schoolhouse Hill Road will be closed and traffic will be detoured around the closure. The 1.8-mile detour shown on this slide utilizes Schoolhouse Hill Road, Walnut Tree, Hill Road, and Edmond Road, and takes about 4 minutes to drive. This closure is anticipated to be in place from spring of 2029 to fall of 2029, with the goal of limiting the duration as much as possible. Thanks. I'm going to pass it back to Daniel for the rest of the presentation.
Excellent. Thank you, Sam. So now turning our attention to additional impacts. Thankfully, with this site, we have a lot of space to work in, so we don't anticipate any right-of-way impacts due to this project. In addition, given the nature of the site, we have no permit-required environmental impacts. And in terms of utility impacts, there is only one utility in the vicinity, and it's an overhead communication wire that is along Schoolhouse Hill Road. However, we anticipate that the construction can be performed without impacting these wires. Next, please. Finally, I'll turn to the project schedule and costs. I will mention that these costs and schedule are preliminary because we are still fairly early in design. So these are subject to change. But the overall cost of the project is anticipated to be approximately 11 million. This cost will be split between federal funding and state funding. And then the construction schedule will predominantly fall during 2029. The project will begin in spring 2029, and the bulk of our effort will be done in the fall, but overall construction will end in 2030. This is therefore essentially a single season construction project. And with that, I would like to turn it back over to Francisco to close us out.
Thank you, Dan. Next, I'd like to say it again. This is the Q&A session that starts. You can reach us by email to dotproject 0096-0209 at ct.gov, and you can also reach us by phone by dialing 860-594-2020 and leave us a voicemail, or at 860-594-2078. Call Francisco Fadul, who is the project manager, and also by the Zoom Q&A. And also, if you like more information about the project, you can access the webpage at portal.ct.gov/DOT Newtown 0096-0209. And last, I would like to let you guys know that the coming period is open through September 3rd. Thank you.
At this time, this is the Q&A session as mentioned. If there's any questions, please drop them in the webinar chat or the webinar Q&A. We'll be standing by 1 more minute as there's no questions time being. Great. There are no questions at this time. Thank you, everybody, for joining. Well done to the presenters.